Hi, everybody. Good afternoon. Welcome to the second part of the ntop conference. Today, Simone will lead the session, and this session will be about ntopng. We have several guests today, and the idea is that Simone will give an introduction to the new feature of 4.2, and then later our guest will speak. So I let Simone take over the screen and start the second part. Thank you, Simone.
Thank you, Luca, for the introduction, and thank everyone for joining us today for this second day of our ntop conference 2020, which is virtual only. And yes, as Luca said, today I'm going to start this session with an introduction of the new ntopng 4.2. I mean, we have already seen the main features during the previous day. So this time today, I would like to show the new features using a by example approach. So we are going to see real cases, see real examples of how the new ntopng 4.2 features can be used in practice. Then our friend Justus from CheckMK is going to show how the REST API of the new ntopng can be used to actually create integration with other software. Then the inline capabilities of the ntopng features will be presented by Cristiano Bozzi. So basically, Cristiano will show how to use ntopng as an inline policy to control the network traffic. Then we will have Giordano Zambelli. Giordano will also show real use cases of ntopng. So basically, how he uses ntopng to solve real problems, to diagnose network issues with his customers, basically. So he is going to show how ntopng is helpful in this kind of analysis. And eventually, Christian Ferenz from Cubro will demonstrate an integration of ntopng in the Cubro Omnia platform. So this is basically a way to integrate an existing appliance to improve the capabilities of existing appliance to monitor the traffic. Okay, so let me start this presentation with the new features of the new ntopng 4.2 using this by example approach. So in the next 30 minutes, I'm going to talk a little bit about the new features of ntopng, and then I will just jump to the live demonstration. We are going to see the new behavioral analysis of ntopng, and then a little bit more technical, we are going to see how to diagnose TCP issues. So basically monitor the TCP health and status. And I will conclude the presentation with some examples of the enhanced SNMP support in ntopng 4.2. Okay, let me briefly recap the features of the new ntopng 4.2 for those of you that couldn't attend to the previous day of this mini conference. So in this latest release of ntopng, we focused more and more on the security aspects of network monitoring. So we have added to the traditional monitoring already supported by ntopng, we have added an increased focus on security. So we have extended it with behavioral traffic analysis, among which the behavioral analysis to detect unexpected services or periodic patterns in the traffic for lateral movement between hosts in the LAN. We also focused in the analysis of the encrypted traffic. We've improved the analysis of TCP and enhanced the SNMP support. In addition, we have worked a lot on the way alerts are handled by ntopng to create a pretty flexible way to send alerts to downstream recipients using severity-based or type-based criteria. So you can decide to send security alerts to Discord or network alerts to Slack, for example. This is a pretty interesting topic that I'm not going to talk about this today, but my colleague Matteo is going to give a full demonstration the next week during the third day of this conference. Then we have also extended a lot the REST API of ntopng. And later today, during this presentation, Justus is going to show an example of the ntopng REST API and how this REST API has been used to create an integration of ntopng. Okay, so let me start with the examples. Let me start with a behavioral traffic analysis that can be done using ntopng 4.2. Let me just give you real examples, basically. So not a lot of theory, just practical and real examples. The first example that I would about is detection of unexpected services. What does it mean to detect unexpected services? It means to uncover services in our network that are somehow used and that are not allowed by our organizational policies. A quick example can be the use of Gmail addresses rather than corporate addresses. I mean, our organization can ask employers to only use corporate email addresses and not Gmail. Another example can be to have people inside the organization to use organization DNS. So maybe we serve protected and filtered DNS server, and we want our people to use our DNS servers and not external DNS, I don't know, maybe Cloudflare or Google or something else. So this is why it can be useful to detect unexpected services. The other thing, it's more security oriented, is to make sure no rogue, no suspicious services are being run in the network. This means, for example, we want to make sure no one is running a rogue DHCP server to intercept the traffic inside our network. And least but not last, unexpected services can be used as a signal to detect the so-called lateral movement. A lateral movement is basically a movement between two hosts in the local network. This is typical in a scenario of network security where you have an attacker that takes the control of a host in the network, and then it tries to access sibling hosts using open services. So these are examples of why it's important to detect unexpected services in the network. And now I would like to show you the first demo to detect attempts at using unauthorized DNS server. So let me just take my ntopng So I'm going to start my ntopng now. Take my web browser. So to detect unexpected DNS services, we have created and provided a user script called unexpected services. So we can go to the flow user scripts and configure our unexpected DNS user script. So here in the configuration of this user script, I specify a list of DNS allowed by my organization. So I can add 111, I can add other addresses here as well. And then when I'm done, I can save this configuration. From this point on, ntopng, every time it detects DNS traffic, which is not directed toward any of the addresses listed here, will raise an alarm. So let's try this in practice. To try this in practice, I can start making DNS requests. So I can use dig and ask server 1111 the address of ntop.org. 1111 is listed among the allowed DNS servers. And indeed, if we look at this flow, there is nothing wrong. Let's have a look at what happens when we try to contact a DNS server which should not be used. I can do the same and maybe use the Google DNS 8888. So this time, I would expect an alert. And indeed, we have ntopng that immediately tells us, hey, there is an unexpected DNS server found with address 8888. So as soon as there is this kind of traffic detected, an alert is detected and it can be possibly sent to downstream retirement. So this is our alert. I have shown the example using DNS servers, but there are similar user scripts that you can use to detect unexpected DHCP servers, unexpected SNMP servers. So the example of the emails that I've told you before, and also unexpected NTP servers. So let me continue now with this presentation and with another real example of unexpected services. In the behavioral analysis of ntopng, we can detect on a host-by-host basis the whole map of the services offered or used by an host. So to enable behavior analysis, you need to go to the preferences, MISC, and make sure this toggle is set to on. From this point on, ntopng will start implementing heuristics for the behavioral analysis. As I've mentioned, the first thing that we can see with the behavioral analysis is the service map. The service map that we can access for every local host in the network, the service map shows us all the services used, accessed, or offered by every host in the network. So, for example, this host 222 is being accessed via SSH from my MacBook Pro, and indeed we have typed SSH Simone at Devil, but this host is also accessing another host via SSH. So there is not only SSH, but as we can see from here, we have services for ICMP, HTTP, and others. So just looking at this page, you immediately have an idea of what is going on inside this particular host. But this is only a part of the story, because what you can do using these service map is to also generate alerts when a new service is detected. Indeed, I can try and let me show you this with an example. Now I'm in this host and I can try and access another host via SSH. That's the password. And now I've accessed this host via SSH. If we jump back to this page and refresh this, we can find an extra row here that is telling us, hey, this host has accessed APU on port 22 with the service SSH one time 13 seconds ago. And we also have SSH information. So this could have been the lateral movement of an attacker that is trying to access a sibling service, or this can be a normal activity. But anyway, it's something that is worth to be seen and detected by ntopng. This also creates alerts, because if we look at the alerts, we see that a lateral movement has been detected 5 seconds ago between Bevel and APU on port 22 with application SSH. This is the exact lateral movement that we have generated using the SSH connection that ntopng has detected, and it has also created an alert to notify you about these possibly suspicious, not necessary, but possibly suspicious activity. If you want to see these alerts, you have to go to the user script settings under the interface and make sure the lateral movement detection user script is enabled. Another interesting thing that we can do with the behavioral traffic analysis provided by ntopng 4.2 is the detection of periodic application. What does it mean? It means that ntopng implements heuristics and techniques to detect traffic that is exhibiting periodic behavior. Is this good? Is this bad? Well, it's not necessarily good or bad, but it's something that should be monitored and detected. It can be good to have periodic application traffic. For example, when you have a monitoring application, such as CheckMK, that periodically monitors your host in the network. It can also be a suspicious activity if you have a scanner that is periodically trying to scan the host in your network. It can also be suspicious because it's widely known that there are families of malware that tend to behave in a periodic way. That is, there are malware that operates generating just a low bandwidth traffic, but periodically. So detecting periodic application can be important as well. It can be important to detect normal or possibly suspicious behaviors of an host. So how to detect periodic behaviors of an host? Similarly to what we have seen for the service map, ntopng features a periodicity map. That is a map that highlights all the services used or offered by an host that are showing a periodic behavior. And since they are periodic, ntopng also gives us the frequency, that is how often this service is being used or offered. And we can see another example of these periodic services. We can pick one host. Here we have like a clock, and it tells us that this host has 3 services active. One is TCP SSH with frequency 60 seconds. And this is a periodic check. This is indeed a periodic SSH check. As we can see from here, we have check_SSH. So this host is periodically every 60 seconds checking SSH on this other host. Then we have an HTTP server, which is being accessed by my host. And here we see a periodic traffic, periodic with a frequency of 2 seconds. Do you know what is this frequency 2 seconds HTTP traffic? It's just us that we are using the web browser to connect to this host via HTTP. Since the web browser tabs refreshes every 2 seconds, ntopng detects this as a periodic service with periodicity 2 seconds. So in this case, this is normal. This is okay. But there are also situations and issues that can signal for suspicious activities or for unexpected activities. For example, I would be worried if I see protocol unknown in a periodic activity. Let me show you how to create some other periodic activity that can be detected by our host. Let's try and run a 4e in 100. Let's try and do a periodic ping of, I don't know, this guy. Sleep 3 seconds, 2 seconds, and then done. So now in this small shell script, I'm trying to ping host 225 periodically, and then I'm going to sleep 2 seconds. So I would expect ntopng, so maybe there's something wrong, ping 1, okay. So now I've started doing a periodic ping toward this host, so I would expect ntopng to learn this periodic behavior and to tell us this periodic service inside the service map. We can try and refresh. And indeed, here we have our line with protocol ICMP because we are doing the ping. We have the destination, which is Devil v5. Devil v5 is the symbolic name for host 225. I can write Devil v5 here, and it's the same thing. And as you see, the number of observation increases. Every 2 seconds, there's one more observation, one more, and more. So this creates an overview of the services, of the periodic services that are taking place in your network. And of course, these periodic services also highlight alerts. So you can receive periodic service alerts that you can browse and have access, historical access to all the alerts that are generated using these periodic services. Okay, so this is the example of the ping that I have already demonstrated. So we can pretty quickly go through this slide and move to the next part of this presentation. So TCP health and status using ntopng 4.2. This part can be a little bit more tricky, maybe for those of you that are not really familiar with TCP, but I'll try to keep it as simple as possible. So why it is interesting to monitor the health and status of TCP? Oh, I mean, you know, TCP is one of the most popular protocols that are used at the transport layer. So basically to move data in the network in a reliable way, well, TCP is likely the protocol that is, it's likely the most popular protocol. But the performance of TCP is fundamental because a poorly performing TCP can cause poor user experience in general. So degraded experience of the network, degraded quality of certain servers, of certain services, web services that are slow, that have a high latency. So monitoring the TCP is pretty useful to make sure the services that are offered in our network, that are offered or used in our network, are working as expected, are working properly, and so the users are experiencing a good quality of experience. So to monitor the TCP health and status and to know if TCP is performing poorly, we can look at the throughput, or we can look at the retransmissions and packet loss. This means that, as I've mentioned, TCP gives us a reliable delivery of data in the network. So it figures out, it detects packet loss, it supports retransmission when it detects that some packets are lost or are delayed. So we can look at all these TCP metrics to somehow detect and tell the user this TCP session is good, this TCP session is bad, is experiencing problems. So how to monitor the TCP health and status with the latest ntopng? You have basically a couple of flow user scripts that you can configure. So one is the TCP connection issues, TCP retransmission issues that you can enable. And another one is the TCP zero windows or the low throughput, which is another one. So all these three guys are useful to monitor the health and status of TCP. If you enable them, ntopng will start monitoring at how the TCP is behaving in the network. And let me show you an example of what we can do, of why these plugins are useful. To do this example, what I'm going to do is to simulate packet loss of a 10% in the machine. What does it mean to simulate a packet loss of 10%? Basically, 1 out of 10 packets that are going to or from this machine are artificially dropped by the kernel. So now I would expect, introducing this packet loss, that I would expect ntopng to start detecting a degraded TCP performance. And this packet loss that I am simulating in the host right now is the packet loss that we can expect from a network that has issues or is overloaded or it has issues, basically. So now, by simulating these 10% packet loss, I would expect ntopng to start detecting issues in the flows. So now it's doing this activity in the background. But then if we go to the historical page, we start seeing issues in the detected alerts. For example, we see a lot, here we see TCP issues with a severity of warning. So our ntopng is telling us, hey, TCP is behaving poorly. Something bad is really going on because there are many packets that are being lost or arrived out of order. So when we see the warning here, we know that it's pretty relevant for the TCP. It's worth inspecting the TCP because it's having very poor performance. Similarly, we have these alerts that are called low good put flows. A low good put, without going into the details, is that a lot of the traffic spent over this TCP session is controlled traffic. So the payload of this traffic is a fraction which is not enough to consider this flow normal. And indeed, when we see this behavior, it means that the network is performing poorly. So TCP is exchanging a lot of controlled traffic just to ensure a reliable delivery of data. So using these metrics, you can use these two user scripts to detect the health and status of ntopng. Let me remove now this rule so that our machine can start functioning normally again. And let me show you another interesting example of the TCP. This example is about the TCP zero window. So the TCP uses some buffers that we can call windows to temporarily store data that is transferred over the network. Why it is relevant to read this TCP zero window? Because the TCP zero window is a signal that TCP is telling, hey, the buffer is full. The application is not reading data fast enough, so the buffer is full, and I have no more room to store extra data that is arriving from the network. So this tells you the application is low. The network is okay, TCP is working, but the application is low. So this is important. This is important when it comes to monitor the application performance, because this is a metric that highlights the application performance. Let me show you how we can create an example of a TCP zero window using a shell. I can jump on a machine. So now what I'm going to do is to transfer some random data over the network and simulate the TCP zero window by stopping the server that is receiving this data. So I'm just using netcat. I've started a netcat server on port 1235 on this host level v5. And now I'm going to transfer using netcat random data to this host 1235. So let's see what is happening. Here we are. We have our flow that is transmitting data at 36 megabits per second on port 1235. This is exactly the flow that we have triggered using this netcat. What I can do now is to hit Ctrl-Z to stop the server process. So what happens now is that the client process has kept pumping data to the server, which is stopped. So the TCP window goes to 0 because the server is stopped. So the TCP buffers of the servers are filled and there's no more room to receive extra data. So this has caused a 0 window alert. I can stop now the two services, and we just have to wait for this flow to go idle. And then ntopng will tell us, hey, this is a 0 window flow. Again, a 0 window flow. Now it's going to take a bunch of seconds. This is going to tell us, here we have our service. This is the alert that is telling us this is a TCP 0 window flow between Devel and Devel v5 on port 1235. So again, if that would be a critical business application, that would definitely be useful to tell us, hey, this business critical application is performing poorly because the network is fast, but the application is not receiving data fast enough. And this concludes basically the second part of the presentation with the monitor of TCP health and status. Now we'll just spend a few words on the SNMP. There's no time to actually show a demo of SNMP, but yes, keep in mind that in version 4.2 of ntopng, the support for SNMP has been greatly improved. So it's faster. You can poll many multiple devices. It's faster, and you can also create network topologies using LLDP. It's also worth mentioning that in version 4.2 of ntopng, there is support for SNMP version 3. As you know, SNMP version 3 supports encryption and is used in banking and finance. So it was a must-have feature for ntopng to have SNMP v3, and we have added SNMP v3 as well. A few words on an interesting user script that you can use to mitigate the hosts that are behaving, that are suspicious, basically. If you have SNMP enabled, you can use ntopng to physically disconnect by turning the SNMP port down of hosts that are suspicious. What ntopng implements a metric called score that is used as an indicator of compromise for hosts. So it can actually use this indicator of compromise to block, so to physically turn the port off for hosts that are suspicious or likely compromised. So this concludes basically my presentation. I would like to briefly conclude this presentation just with a recap. So basically, this ntopng 4.2 has evolved to focus more not only on the traditional monitoring but also security. We have seen real demonstration of behavioral traffic analysis implemented in ntopng, and we have also seen how the health and status of TCP can be monitored. Now, I would like to have Jan Justus from CheckMK to continue with his presentation. And as I've told you, he's going to talk about the integration of ntopng and CheckMK. Then we will have Cristiano Bozzi. He will show how ntopng can be used as an inline policer, and then Giordano Zambelli, that he will demonstrate how ntopng is used to solve connectivity and network problems, but also security problems with his customers. And finally, we will see the embedding of ntopng in the Omnia appliance by Christian Ferenz from Cubro. So now I would like to have Jan take over this presentation. So Jan, please feel free to share your screen and to start your presentation. And thank you.
Perfect. Can you see that?
Yes.
Very good. So thanks a lot, Simone. So I'll talk a bit about the integration of CheckMK, a monitoring system with ntopng, essentially along 4 lines. Quickly an intro to CheckMK for those who don't know it. Then primarily the use case for the integration. Then how it looks like. So how did we actually use the REST API to integrate? And then lastly, how can you actually test it out, since it's just about to go live? Maybe a quick word on CheckMK. So CheckMK, what it is an infrastructure and application monitoring system, has been around for many years. And essentially, it focuses on monitoring 3 different things. One is large, complex on-premise environments, so all kinds of servers, applications, databases, storage systems, routers and switches. That's our network domain, and sensors such as humidity and temperature sensors and databases. So one angle. Second angle is everything around modern containerized environments, Docker, Kubernetes, OpenShift, and 30 major public cloud environments. Now that's a complex world, and in that complex world, essentially you want to not look at it the entire time. You want to be alerted if something happens. And so we have a variety of alerting mechanisms based on pre-configured thresholds and thresholds that you can also adjust to alert the different operations teams if something happens, the database teams, if a database problem arises, etc., via the classical means or more modern means like Slack, PagerDuty, etc. You can also export it to Grafana to also visualize it with other data that you want to have joined in Grafana, or you can export it to CMDBs, such as I do it, where you essentially then combine an asset view. This is the static infrastructure that I have, with a dynamic view. This is how much the memory of that host is used up, etc. And so there's a very broad scope in that area. Now, because that infrastructure is so heterogeneous, we need to develop lots of connectors, lots of plugins to connect to all of these different vendors, their different devices, and etc. And so don't want to go through this, but basically for all kinds of vendors out there, we have a plug-and-play system that connects to those. And in many cases, it actually comes with predefined thresholds based on what we've learned over the years are the relevant thresholds for these different devices. One area is network monitoring. Come to that in a second. Now, essentially, we have 2 versions. I'll talk about that on the next page. One is an enterprise version that is basically has grown very well. We have now close to 3,000 customers. We serve most of Germany's largest corporations, which is our biggest market, but you can have it in lots of countries, and we have a subscription that is renewed by most customers over 95% every year, and you can see some of the customer logos there. And we have an open source edition, similar to ntop. We have what's called an open core business model with an open source edition and a commercial edition, and many more than 10,000 users in the world are using that to monitor mid-sized environments. And these are essentially the 2 worlds that we offer. CheckMK Raw is our open source, our community edition. It's built on a different monitoring core, which is medium performance. It's an Argus core, but we delivered with all these connectors that you saw. So if you want a good plug and play system, it comes with it, has community support, is free. And we have an enterprise system which has its own built-in core. It's very high performance. It can handle what's called ephemeral infrastructure, so container environments that are there and then disappear again, has lots of advanced features, etc. And we typically go the classical route. We introduce features first in the enterprise edition, and then they move downstream. And this is also the case with the ntop integration. It starts as an enterprise feature, ntopng and CheckMK, and over time we might also add something in the open source edition. Now the team is working very hard on a major upgrade. We will call it also CheckMK 2.0. It has been rewritten in many parts, has new REST API, etc. Looks much more modern in dashboarding. And the ntopng integration will become one of the features it will be launched essentially with CheckMK 2.0. Because over the last years, we had many of our customers that said, I'd actually like to do network flow monitoring. And that is how we started the collaboration with the ntop team to integrate these two tools. Now, having said that, what is actually the use case and how are we thinking about it? Now, essentially, CheckMK for many customers is their central monitoring system. So our use case is essentially you are a CheckMK user, but you want to benefit from the deep know-how of ntop. And so essentially, as I said, many of our customers buy CheckMK only for network monitoring. So you can do quite a lot of things with it already. You can get the bandwidth, the packet rate, error rate, the network status with lots of defined thresholds. But then there are cases which you all know where you want to look deeper, either to really go deeper on a root cause, such as identifying, where is the bottleneck originating, to get more visibility, such as to who the top talkers are, to get more in-depth performance metrics than CheckMK offers, or to some of the cyber features that Simone just alluded to. And in that case, it's very beneficial if you have the ntop system in parallel to ours, and you can navigate from our system into ntop system in case you want to look deeper. And that's also how the direction of the integration is designed. We want you to have a lot of the standard functionality in ntop available in the CheckMK user interface. And when you need to go even deeper, then you really have to switch system and go to the ntop UI. And we set them up in a way that the UIs actually look similar, so you don't have to reorient yourself in the new system. So for CheckMK users, essentially it means you get more deeper network capabilities. For ntop users, it means you can become part of a broader infrastructure monitoring system, which often is the main alerting system for the operations teams. And that's, I think, what many of our customers find very beneficial. Now, how does it look like? And this is essentially some of the features that were made possible through the REST API integration of ntop. Now, essentially, this is a simple starting screen to show where we start off. In many cases, you want to start with a host which has a problem. And in our case, this is a very simple listing of different hosts here. You can see it whether they are up or down. And on the right side, the numbers and the colors you see are essentially the metrics that we look at for a certain host. And if they are red, there is something wrong. So we can assume, for example, there is a host which has a bandwidth issue, and then we would look for that host and see, okay, let me actually look at ntop details for that host. And we would go through the host view that you know from ntop and that we essentially copied into CheckMK, again, to make it easier for you to switch around in these tools without having to reorient themselves. You can see on the following screens that lots of things still need styling. We'll do that fine-tuning at the moment. But essentially what you can see here on the horizontal axis are the tabs that you're familiar with from the host view in ntop, so the host overview data, the traffic data, the packets, etc. And then same as an ntop, you can now for that specific host switch through these different modes in CheckMK. So you can look at the overview, such as, for example, how much data was sent. You can then look into the traffic. It's basically as you've seen it in ntop, which protocols are we using, which protocols transmitting how much data. So I'm jumping now a bit You can look into the port screen that you also know. We've also integrated the deep dive. So if you click on the client or the server, you could have more detailed data. You can look at the peers. This is, for example, now our CheckMK, our headquarter Munich, and this is our build server as to how they communicate over which protocols. And that is basically goes on until about here or here, where we integrated all host views into CheckMK. Similar for the applications, you can have deep dives into the different application types as you would have in ntop. And so it gives you a very easy means to look at this problem using the ntop technology in CheckMK. Now, ntop also has other dashboards. We saw some of them with Simone, so we also integrated the main dashboards. So this is the example of the alert dashboard we just saw, which we provided a small gimmick. The gimmick is essentially that you can not only filter here on that level, but you can also filter graphically by scanning through a date, and then for that date specifying a time, and it will only load that data. As you can see, styling is still not optimal here. But then you see the typical alerts view that you can see in ntop and analyze for that. Similarly, a second example, the flow view. It's a bit squashed here because we took a smaller screen size to make the screenshot, but it's the same as an ntop, so you can have the same view without having to switch between the tools. Now, in summary, we integrated the main dashboards, so the traffic dashboard with the top talkers. That one is the last one, still work in progress. The alerts that you just saw, you can trigger alerts from ntop and CheckMK. The way to do it is essentially you configure syslog alerts in ntop, and in CheckMK we have something called the event console, which listens for events on a certain port and then trigger an alert in CheckMK. So that's the alerting path. You have the flow dashboard that we just saw, the detailed host information that we just saw. And now this is all essentially copying ntop's user interface, so you don't need to switch. But on the other hand, we also wanted to make it easy for our customers to integrate certain aspects only in certain views. And this is what we call here the building blocks. So they are actually taking specific graphics or specific analysis out of ntop and putting them into a different CheckMK context, such as a dashboard. This is essentially what the integration is all about. And I think the REST API was super helpful for us in making that happen and in providing that integration. Now we are just about to get started. We have released the first beta of this 2.0 version, which you saw this week actually. It does not yet come with the ntop integration. Since we are finalizing a few details, the ntop integration will be released with the beta 2 or beta 3, which is roughly in 2 weeks or so. And from then on, it's essentially you could test it out whether you like it. And so this is a bit the time frame for our integration. This is the beta phase that I just spoke about. End of January or in February, we release a stable version. From then, this becomes a standard part of CheckMK. Initially, you need to, because it's then an ntop commercial piece and a CheckMK commercial piece, initially purchase it from these two vendors, from ntop and from us, or from ntop's reselling partners. And over time, we actually want to make it a one-stop shop so that you could, if you come from the CheckMK side, buy that from our side as a whole package. Now, for you, if you're interested in testing it out, there are a few ways. There is one way where you download a beta free edition. It's called on our website. It's basically the commercial edition, which is a very reduced subset of hosts, but it comes with the ntop integration. You know your ntop very well, so it's easy to set it up. That will be available, as I said, roughly 2 weeks. Or you can write to our sales team and say, I would like to have access to an unlimited trial if you want to test out something bigger. But that's the part, and thanks a lot, Simone and Luca, also for spending the time with us and helping us technically to make that work. And I'm very looking forward to both the collaboration between the companies and also to the customer feedback as to how they like it, what other features they would like to see, etc.
Yeah, thank you, Jan. Yes, it was very special for us to cooperate with you, CheckMK, because we believe that both CheckMK and ntop share the same philosophy of an open source core. So we believe that with this integration, we have demonstrated that by integrating two projects that have an open source core, we can create an added value for the final user, for the final customer, which is pretty unique. So thank you, Jan, for this presentation and for this contribution. And now I would like to have Cristiano Bozzi to continue with his presentation and escape the smart control of your network. Cristiano, please, you can share your screen and start with the presentation.
Hello? Can you hear?
Yes, Cristiano. Yes, we can hear you. Yes. Now we can no longer see your screen. Can you please share it again? Cristiano, we could see your screen until a few seconds ago. So maybe. Cristiano, can you hear me?
You can hear me?
Yes, yes. Can you share your screen if you are having difficulties?
Okay, sorry, I'm trying to show you again the monitor. Okay, can you see the monitor?
Oh no, yes, we can see.
Okay, sorry for this. Sorry for this. Okay. Thank you for this opportunity. Thank you to Simone. Hi everyone, and I'm Cristiano Bozzi, and I'm the responsible of the nautical market of Nextworks. Nextworks is a very strange company. We have two divisions. One is the pure research and development division. The second one is a product division. And inside the product division, we have a dedicated nautical team. And what we do on nautical, we are involved in integration of IT components and IT services on board of mega yachts, starting from 30 meters up to more than 100 meters. So we started this job, I don't know, starting since 10 years ago, more than 10 years ago. And we are going to install on board the services like VoIP or CCTV or video on demand, audio video environment, and in particular network monitoring and control. As you can imagine, in the last few years, the integration of this kind of services inside the IP network is increased. So we start with a lot of analog environment and analog devices, but in the last 5-6 years, all the services that are released on board pass through an IP network. So we started a few years ago to have some issue in order to monitor and to manage all the traffic that were installed, that were used on board from every single services and every single device that can be installed or can be not installed, but imagine used from any user. Imagine that you can have more than 20 users, and each user on board can have an iPad, iPhone, PC, and whatever. So traffic is unbelievable, and every single issue, every single problem that this kind of traffic can create on the network, this can influence all the services that are being managed on board. So we started this collaboration with Luca, with the ntop team, in order to manage and to create some products or some software that can help us to monitor and to manage the traffic on board. And starting from the ntopng version, that was the standard version, we arrived to the nEdge version, that is a particular release of ntopng that has some extra feature respecting what is the standard ntopng version. And this kind of extra feature are in particular related to manage the traffic and manage the routing policy between users and to manage the access to the network from different users, which was the most important thing that we were looking for. In particular, we were looking for a smart interface. It should be an interface that has to be useful, but it has to be simple for the end user, because on board of a super yacht, a giga yacht, there is no IT manager. There is no people that are able to understand the networking traffic or to manage, I don't know, a very expert interface like Cisco OS or something like this. So we need for something that is very, very clear, very simple, and very useful to be used. The second one was to add to ntopng a user management and control interface. So we have to be able to distinguish and to split every traffic that is on board for every single user. What is a user? A user can be a people that, for example, is the owner, that can have different role inside the boat, or can be a group of users. Imagine that it can be crew members, guests, VIPs, something that. So we needed to split the behavior of each user, and then we have to control the traffic and to limit or to blacklist some users in order to give, for example, to the owner more bandwidth or more services, something like this. At the end of this kind of services, we need to have a reporting and monitoring system that in every time and in each situation is able to give us an overview of the bandwidth of the network, of the health of the network on board. This is very important because where you are in the middle of the sea, you have poor connection and the traffic is very important. The health of the network is very important. So we started to work with nEdge, and finally we have since 5 years, we have a good version of nEdge. And in what way we are going to use this kind of interface? In particular, we are able to create dedicated profile that can be used, for example, at home. And so you can define that you can have a kid profile or a teen, an adult, and for each profile, you can define a sort of categories or protocols that can be controlled in time. So you can have, I don't know, not more than 2 hours of YouTube services, or you can blacklist services like Facebook, like, I don't know, Emule, or whatever you want, or even you can put offline completely some devices or some services. It depends from the traffic, it depends from your rules or from the people that are at home or are on board, and then you want to control. The same situation can be used, for example, for a business environment. Imagine that you can control the traffic, or you can limit the traffic to the employers in a business situation or in an office, or I don't know, in a bigger network. But the most important things and the most important environment, as I was describing before, is the yachting environment. And in the yachting environment, we have a more complicated situation, because when we are on board, usually there is no only one channel in order to connect the boat to internet. So usually you can find a Wi-Fi gateway through while you can connect the boat to an access point in a shipyard, in a port, or whatever. Or you can use one or more 4G, 3G mobile gateway in order to connect the boat to internet, or a VSAT connection. you are not always able to use all the channels or to prevent which is the channel that will be better or that can be used at the moment. So with the NX Gate, that is the name of the product that we are using, and that is based on ntopng and in particular on an nEdge version, you can define a routing policy. So you can define which is the channel that you want to use and in what kind of priority and the way you want to use it. For example, you can create a load balancing channel, or you can create a failover situation. I don't know, for example, you can be around in a port, so you want to give the priority to the Wi-Fi channel and stop to using VSAT. That is very expensive. But if you can have a problem to the Wi-Fi channel, or you can go into the SIA, so the Wi-Fi channel will stop to work, and you can have an automatic failover situation, so that the bot will jump in an automatic way to a channel like VSAT. And when you go near the Earth, so that's okay, you can jump over to a 4G or something like this. This is very useful because you don't have to do nothing. This is all is automatic. You can decide your profile, you can decide your routing policy, and then you can apply this kind of configuration, and the system will be able to jump from a channel to another. And in particular, then you can define some user that can be on board. Imagine that this should be the owner, guests, captain, crew member, a VIPs member or something like this. And for each member, you can define one profile in order to application usage. Imagine that the owner is more or less like God. He can do everything. But crew members can be limited in some functionalities, not always in terms of bandwidth, but also in services. So, for example, if you have a very poor connection, you can decide to stop completely every not working services, let's say, like, I don't know, WhatsApp, Facebook, YouTube, or something like that. So crew member can send an email, more or less can browse, but can't for 2 hours, 3 hours, or whatever, send a YouTube video or download a Facebook image or something like this. And in that way, you can control the bot in a very simple way. In particular, we integrated in an Edge a captive portal solution. So when the user wants to connect to internet, he will be asked for the username and password, and in a very stupid and simple way, he will be able to go through internet, inserting username and password. There is no MAC, there is no IP, there is no very complicated, let me see, for a normal user terms or situation from a TCP or from network or something like this. You have to be connected to the network with the username and password, and then the network will decide what it can do and in what way it can move around the internet. And then with the monitoring system, with the report system, the system administrator, that is not a TCP expert, is not, I don't know, is a network guru or something like this, is in any case able to detect bad functionalities or, I don't know, traffic, not bad behavior, or all the things that Simone was explaining before, that on board can be very, very important, because in every moment, every day, I can check the status of my network, and then I can say if all my services, all my bot is going on in a very good way or not. And thanks to ntopng and Edge in particular, we are able to do that in a very simple way. So we created our own product, and we created the capabilities of a captain that, as I was describing before, this is not an expert of networking or is not an expert of TCP IP or something like this. But in any case, it's always able to control, to monitor, but to manage the behavior of all the users on board regarding and respecting the networking and the internet connection. And this is more or less all what we are doing with the nEdge version of the the ntopng. So I have to say thanks to Simone and to ntopng teams for the support and for the nEdge version that is a very particular version and of the ntopng.
Thank you, Cristiano. With Cristiano, we have been able to grow our software suite, and in particular to grow ntopng to be not only a passive monitor, but also to be something that can be used in line, that can be used to filter the traffic and to block unwanted traffic. And thanks to Cristiano, we have been able to develop these into a very special environment, which is the environment of yacht, where the connectivity is limited, where you are in the middle of the sea. So there are special challenges that we have been able to face and to resolve interesting problems and to make our ntopng function in this environment as well. So if you want to know more about the inline version of ntopng, you can look for a product which is called nEdge, that is basically a fork of ntopng that offers inline filtering capabilities. So thanks again, Cristiano, and let's continue this presentation now with Giordano Zambelli, that he's going to tell us about the real use cases of ntopng, how he uses ntopng to solve network and security problems with his customers. So Giordano, please feel free to share your screen when you're ready and just start the presentation. Yeah.
Hi guys. Do you see something on your screen?
Yes, we can see and we can hear you okay.
Okay. Thank you, Simone, and thank you all ntop teams. Okay, why this title? To be or not to be? ntop is a fantastic tool. So I am the CTO of Verso, and Verso is a very vertical company specialized on security infrastructure and consultancy. So every day we are in a mood, because in this day the cybersecurity is very stressed for the attack that all of you can know and can learn from the newspaper site and so on. So we starting from since 5 or more years ago, we start to use ntop like a baseline for starting every hour discovery and our activity and our assurance of traffic and customer infrastructure. Okay. First of all, who am I? I am Justus Zambelli, I'm CTO, and Verso is very specialized on security solution, like I told you before. And customer asking us not only the solution, but they are asking us something to help them on a troubleshooting purposes, because the networking are growing very fast in terms of bandwidth, in terms of connection, in terms of needs. So it's not so easy to find a problem. It's not so easy to solve and to fix the problem. So we found on ntop a special friends, a special IT friends. So this is why we decided to share with all my team and ntop team. We decided to share some use cases that allow us to do a good job on customer problem. Like I told you before, networks are growing at a very fast rate, are expanding because with starting of the pandemic problem with COVID, the network was growing and expanding, but now the network are more expanding because the network start and stop to the home office of all the users that are working from smart working. So it's not so easy to manage. Every day, more and more new services are implementing because in that new scenario, in that new normal scenario, sometimes the customer are facing some problem. For example, updates, assurance, vulnerability management, assurance, data control, many things. And one of the main problem is I have enough bandwidth to manage all the things that I need. Sometimes yes, sometimes not. Or other customers need to do assurance because some customers are very big and they have a different business division, IT division inside. For example, network, DevOps, SecOps, consultant, SOC, NOC, and the one that you want to add. And another main problem in this day is cybersecurity. All of us are listening on the newspaper or in the TV news that cyber attacks are increasing in terms of amount and the amount of the customer and the data leakage. So one of the biggest problem is to find the right tool that allow you to listen to the noise. What I mean? To listen what the security device doesn't recognize with a specific signature. So this is the real problem. This is the real plus that we found on ntop and his team. Every day we are facing problem, security, networking, performance, but this is a typical conversation that we have with our customer, and it's the same story probably also for you. In my opinion, something is not working as expected. Okay, share me some metrics, like the guys of CheckMK told. Most of them doesn't have a right vision on the metrics, so it's not easy to find an eye on a pie. Okay. First of all, we want to share 2 or 3 cases that, thanks to ntop, we fix it in a very happy manner, and the customer thanks us. And obviously, we thanks also ntop teams. For example, this is a case that customer was suffering of many download fails, performance issue, and something like this. The evidence after a specific analysis, it was that there was many keep alive session, and keep alive session, and what it mean? It mean that there is something that try to keep alive a TCP session, but what could be in a big environment and a big network, on a geographical big network? Probably some many things. Okay, that could be network, that could be security, that could be assurance. Not a problem. The only one thing that keep our eye open, it was a low good food alert on the ntopng. Okay, at the end of the story, it was a perimeter firewall that was misconfigured. So it creates some problem on antivirus engine, because that perimeter firewall are using, because it's already up and running, are using security service in proxy mode, in transparent proxy mode. So when you think that you are downloading package, or you are taking packages from internet, the security service in the middle try to avoid some security issue. But sometimes the misconfiguration or size problem depend on the vendor, or other type of problem during the antivirus engine and security engine, intrusion prevention, and so on, close the connection, and for the end user experience is that something is wrong on the internet. So thanks to ntop, with the low good put alert, we discover in an easy way. Another case is it's a typical use case. That's something related to verify security effectiveness. Probably all of you has some technology, some IT security and cybersecurity solution technology in the architecture that allow to find everything. But the most important thing in that market is to verify if all the technologies are up and running, are ready to answer and to create alarm. In that case, as you can see, many IOC indicators of compromise share with some agency, NSA, national state, and so on, ask you, or better, sorry, suggest you to put some ACL in place in order to prevent some type of attacks. For example, blocking some country, blocking some IP address, and so on. But okay, if the security division put in place the ACL, okay, you could be sure that everything bad was broken, but not every time. So one of the main thing is, okay, but if I have ntop inside of my LAN, and in my LAN I can see an alert that in that example the Russian server is contacted, what it mean? If Russian country need to be blocked, okay, probably someone is not blocking. Sometimes, for example, could be that the JVP list is not updated, or sometimes someone forgot to apply the submit command on the firewall technology. So every time is not so easy, but every time ntop could help you to do the verification phase of a development of every technology or every process. Another case this is a very big company that has, as you can see, many branches all over the world, and okay, they are using they choose Sentinel like a CM because it's in cloud, it has power, it has already correlation engine, it has many correlation rule already prepared, so the SecOps can sleep one time more than before. Okay, but one of the problem of the CM is that they are related to the logs that the technology send them or share with them. But okay, what can SIEM see on the network traffic? Not more, not less. With ntop, we enforce the Sentinel CM in order to discover, to try to correlate, to try to use the scoring that the ntop guys put on the flows. So in that case, ntopng on the very important site, we put it on mirror, and we can see and we can enrich the CM alert with ntop. I put an example. This is the CSV exported directly from Sentinel log, and on the screen there is a typical Sentinel log row that ntop enrich with their security perspective. It was quite complicated activity, but the result is very good because with a single small but very smart sensor, you can enrich all your visibility and all your perception of the security based on correlation. So very good job. Another case, this is ESP, a wireless ESP, Italian wireless ESP, and one of the main things was okay, but I have a bunch of traffic that traverse my autonomous system, and one of the main problems is try to help the end user that suffer from some problem, but they are unaware of the problem they are suffering because they have some malware inside, for example, compromised. So with the ntop view, it was quite easy to find the problem. Sorry, it was quite easy to define the source of problem, but not the real piece of software that create the problem. In that case, I put two screenshots. The first of all, on the left one, you can see the number of packet loss that increasing on that customer. And on the right, you can see the data center view of ntop of that customer. As you can see, this is a small part of the connection. It was about 20,000 connection open. So thanks to the host explorer function and other alarm that ntop can have, it was quite easy to find that there was something inside the customer LAN that was wrong. Starting from that, we can create assurance that on that network there was some problem. So what is the best scenario in order to use the ntop with the all of things? Every customer could be the best scenario, because if you have a small customer or a big customer, keep in mind that if you have this Swiss knife, you can open, you can view, you can analyze, and also you can troubleshoot every type of network. Thanks to ntop, thanks to user script, thanks to all the features that ntop is adding to the new version, probably for a typical IT staff, having a ntop working on a stupid or a dumb device that could be portable could be the best device. And there are many other cases that in which we use ntop to discover and to find problem, but we need to choose and we choose that for, but probably there is no limit. There is only your fantasy the limit about the number of cases that you can apply. One of the main thing, and the one that I cannot insert, is traffic assurance. For example, if you are compromised and you have ntop, remember that all the connection during the incident response procedure, you can find every connection that device done. So don't start to go panic, but simply take out of your wallet your Swiss knife, open it, watch on it, and fix it. Thank you.
Thank you, Giordano. Thanks for showing us all these real use cases of ntopng. I'm glad that you have also shown the log output one, because in the beginning of this day, I have shown a toy example of a log output by simulating packet drop, but I'm glad to see that you have presented a real example of how the log output was caused by a perimeter firewall. So thanks again for these real use cases. And let's move forward with our latest guest for today. And so please, Christian, if you want to start your presentation, Christian is going to talk about Cubro and the Omnia platform. So basically how ntopng has been embedded in the Omnia platform. Yes, please, Christian, whenever you are ready. Christian, we cannot hear you. We can see your screen, but can't hear you. Oh, we can't hear you, Christian. Can you please check your mic? Christian, we still can't hear you. It seems you are unmuted, but there's something that's preventing us from hearing you. Okay, I think Christian is now trying to leave and re-enter this meeting, so please be patient. I would allow a couple more minutes, and then otherwise we can move to the final remarks and see if Christian can fix the issue with the mic. Okay, I think we can move to the final remarks. So, and in the meanwhile, we can see if Christian can make it to the presentation. So, once again, thanks all for being here today. And I would like to tell you that this was the second day of the ntop miniConference 2020. The third and last final event will be held next week on December 10th at the same time. So as guests, we will have Luca Deri. Luca will talk about the latest advanced in ntop and also the integration with OpenWRT. Then Alfredo will show the news of ntdisk and how to run our tool in large networks, so basically scalability in large networks. And then Matteo Viscosi, Matteo is a new member of our team, will give a live demonstration of the rich alerting engine of the latest ntopng 4.2. So how to generate alerts and send them to different recipients, different channels, and so on.
Hello, guys.
And finally, yes, Christian, please wait a second, and then we can go back to your presentation. And finally, we will have Marco Graziano. Marco Graziano will talk us about the ntop Defender. That is another product, basically another inline product based on our software suite. So save the date, next week, December 10th, at the same time, join us for the third day of this presentation. And if you want to join the public discussion, we have a Discord channel. We are very active there. Just join us, drop us messages if you want to try our software, if you have questions, whatever. We will be very, very happy to respond. So now it seems that Christian has sorted out the issues with the mic. So Christian, if you want to start with your presentation, please go ahead and start.
Can you hear me now?
Yes, we can hear you. Okay, now we can also see your screen.
Okay, perfect. Sorry for the issues with all this configuration, but I want to. Yes, my name is Christian Ferenz. I'm based in Vienna, and I'm the CEO of Cubro. Maybe few of you know Cubro already. So we are coming from the top and packet broker business, and we have now developed a new platform. It's not only this product, but we currently talk today about this product because we have bigger ones in the same functionality. And what we want to show today is Omnia 10. Omnia 10 is a small packet broker has a lot of advanced features, and you will see what we can do today. Omnia 10 is a half 19-inch box, and for a reasonable price, and we have 4 link ports, so 8 ports, and the bypass, the tap is included, and then we have another 2 10 gig ports for aggregation or for 10 gig inputs, and we have a console board. But what makes it different than a normal packet broker? It has a powerful quad ARM core CPU. We have RAM in it, and we have a storage capabilities, and this makes it useful for running this as a all-included platform. And the idea is to use this in mid-sized customers because it makes it easy. So you don't need a tap, you don't need an aggregator, you don't need a server. You have everything in one box. So it's one cable connection, and in 5 minutes you have a result from your network. And I think this makes it so sexy that is an easy solution for mid-sized customers. So I want to jump over quickly. So we have the options for tap, so inline, and we have also the option for using this as a spam port. And we do aggregation inside, we do filtering if needed, and we can run analytic software. And in this case, Lucas' team was nice and ported ntopng to this ARM platform. And so we can show today a little bit a few ntopng running on our platform. Yeah, it looks similar to any server installation, but it runs on a small embedded platform with all the features of aggregation and tapping included. Okay, I mean, you know easily how we can do this. So we can use taps. So we have 4 different links, or we can have spam boards, and we can combine this. And you will see it in a second how this can work. And typically, yes, you see the nice screenshots of ntop, and ntop is just an application on top of the Omnia. Okay, so it's really plug and play, nothing difficult to configure. It comes automatically configured. You plug it in, and in 5 minutes you have some results. So this is some of the drawings. I think everybody of you understands. So connect the cable on the other side, and we are doing the tapping. So in the case the box is powerless, we are closing the link, so the link is safe, as you know from any other tap. And in the case you have an optical input from an optical tap, it's 1 gig or 10 gig, you can use these ports, or you can use these ports as well as aggregation output. So in the case you want to use the box as an aggregator together with a normal server, then you can do this as well, of course. Okay, and this is simple. This is the GUI. We will jump then live to the GUI in a second, and then we show you what we are doing. And what you see today is we show our rolling capture, we show our DPI, and then finally we show, of course, the ntopng running on our box. So I think we are waiting maybe for a live session. This makes more sense. So let's go. So we put here the box. So, and you see this is a live box connected in our network. This is our office traffic, and we have some traffic there. And I will go quick over the features. This is the port configuration. This is pretty simple. We have 10 gig, 1 gig, and it's not connected. So we have 10 megabit half, but it's done automatically. So it's an easy way to do connection. This is the virtual port where we present the traffic to any application running on the CPU. So you will see this XV port later on. So this, we have a little bit of port statistic. You see statistic, and you see, okay, where is my traffic? Then this is more important. You can do some aggregation. So what you can do, you configure every port with a tag, and then you configure here where the traffic should appear. And we configure now the G8. This is the port what we are using. This is currently a spam port, and we we do this and we configure this that this comes out on the XV interface, and the XV interface is the internal interface where we send the data to the application. And now we going a little bit to the application. So what we have done here is a rolling capture. But what you have to understand, all these applications, what you see now, they are running at the same time. So we do capture. And so you have here a capture statistic, and now you can select this time frame, maybe based on the data of ntop, and then you get here an index. And with the index, you can start the export. So you can select the time frame, and then you can select an IP address or a port or IP address and port, and you can export a capture, and this capture is then presented. You can open the capture with an online web-based Wireshark, or you can download the capture. So this works at the same time with ntop. This is our own DPI solution. So we also give you information about what traffic, what user is using what traffic. So you see here YouTube, these users are using YouTube. We have OpenVPN and all the features. And we are supporting about roughly 4,000 applications. And if you have a license with us, then we update this every 10 to 14 days. You get a new code, so that you have always the updated versions. And this, what we see here, Teams. This is my connection. So this is my IP address, and this is my connection. So he detects, okay, Microsoft Teams is there. So, and now, because we are on an ntop thing, this is now ntop, and you see here, this is the interface XV. So we get the traffic, all the traffic is coming here. And what you see here is live traffic, a few megabits from our office. I mean, it's late in the evening, so people are not working so hard, so less traffic. But still, the box can easily handle 2.5 gig in this configuration. So we can do 2.5 gig ntop, and we can do 2.5 gig capture, and we can do this on DPI as well. And this is, you see all the features, what you know from ntop is running now on our box. Yeah, and I can jump back and see, okay, I go to the rolling capture, and you see this is working seamless. Yeah, so if you want to really have the traffic of this traffic, you can easily do this by jumping back, put here the custom filter, the IP address and the port, and then you get an export of the original packet, and you can then look at it via Shark or something else. Yeah. So this is the simple and quick. This is the quick description what I can give you. What we do with Omnia, and of course I want to show it at the end the next generation of Omnia. So this is what you saw today. This is Omnia 10. In end of the year we're releasing Omnia 20. Omnia 20 is twice the performance because it has a better CPU, and we added 2 SFP ports, but this is gigabit SFP ports, and we have more storage capabilities, so you can have 2 or 3 M2 SSDs inside, so you have more storage. And this is Omnia 120. Omnia 120 is concept-wise fully the same, but it's a full different league in terms of performance. Omnia 120 has 48 ports, 1 gig, 10 gig, and 4 times 100 gig, but actually it can do the same. Yeah, so we run here, we have a switch included, so a advanced switch with layer 7 capabilities, and then we have 2 big CPUs, 2 big ARM CPUs, and each of these CPU can do up to 100 gig because their CPUs are connected with 100 gig full duplex to the switch. and then we can run applications with much more load. And also ntop can run here. This is our own DPI. This is a DDoS application. So we can do a lot of features on this platform. Yeah. So this is I think it's a quick overview, because I think we are running out of time a little bit to see what can be done on ntop. So we are on Omnia together with ntop, and we are working for ntop together with our box. So that you can have a box which is easy to install, fast to install, and the customer has immediately a success, and he's not frustrated by doing a lot of cables and things like that, what is normally the case when you use it with external boxes like external tabs and aggregators and servers. So this is one box in all, and yeah, I think yeah, I would be happy to have some questions from you, or if you want to test it, please give us a call, and we organize you a demo unit, and you can play around. And if you have some ideas for running software on Omnia together with ntop, please come to us and let's see what we can do together. Any questions?
Thank you, Christian. Thanks for showing this nice integration of ntopng. This live demonstration. And yes, I would like now to conclude this presentation with the final remarks. I think that the take home of the today's session is that ntopng 4.2 has evolved to become a pretty useful tool when it comes to not only to traditional monitoring, but also to security monitoring. And so you can use it to solve real problems in terms of security and monitoring. But if you are a vendor, an OEM, and if you are thinking to integrate ntopng either in a software solution or in an embedded, in an appliance solution, today we have seen that this is possible. We can support you also if you have your product and you want to integrate ntopng in your product to grow and to create an ecosystem together. If there is some time for the question, so I think if any of you have questions, we have all the speakers today that are still in line, plus all the ntop team is online. So if you have questions, please raise your hand or just unmute yourself and ask a question. Okay, let me remind you once again about the event of the next week. So join us for the third and final day of this ntop miniConference 2020. So yes, you can find the details on the blog.
Okay, this is Luca. Let me tell you something about the next event. It will be about mprobe and ntodisk, that are two tools that historically ntop develops since more than 10 years. The first one is about flow collection, flow generation. Jan has shown us a good example of integrating ntop in a business environment, and in many business environments there are flows, sFlow, NetFlow, IPFix. And this is what we'll be talking about. I also will give an overview on what we have done in terms of integration of those tools into small devices, embedded devices, or let's say in agents that it can be deployed at the edge of the network and that can be used to convert flows into something meaningful for ntopng and therefore for other applications, such as, for instance, CheckMK. Then Alfredo will talk about N2Disk. In the past months, we have done a lot of work, in particular for going fast towards 100 gigabits. So we have experience in this type of fields. And also recently, we have done an integration with Arista switches that are able to implement features that are very important for many people, such as hardware timestamping and the network topology visibility. So it means that no longer we are able to dump traffic, but we are able to locate the traffic in a big topology. So this is going to be another interesting topic. Then Matteo will talk about alerting, because out of data, we have realized that many people are not longer interested in play with numbers, with graphics, but they only care, or they mainly care about alerts. So Matteo will tell us how to use them. He gave a quick overview in the last event, so this will be something more in depth. And finally, Marco, that is using our tools, he has created a new tool called ntop Defender. So this is something based on our technologies. So just to give you another idea of how people, again, today CheckMK was a good example, a very good example, how people use our tools to create the products that are based on our technology, but that have nothing to do with ntop. I mean, they use our base as the technology for another product generation. So I hope you will be online next Thursday, December the 10th. Thank you, Simone.
Thanks everyone for joining. And yes, if you have questions, again, we are still here. Feel free to raise your hand or type a question.